Bells here again. This video is for data A. This is for section 6-6. This is on solving. Solving means we're going to try and find out what the value of x is that makes the equation true. Solving both exponential equations and logarithmic equations. I have several examples for you. I'm going to kind of talk through them. Remember, you seeing me do a problem isn't the same as you practicing them. Make sure that you go to the online assignments and you practice the ones that are there. I'm going to tell you some of the reasons why we do the stuff that we do, and hopefully that will help out with it. Good deal? Okay, so here we go. We're going to start with this one right here. And again, remember, you can pause the video and copy any of this stuff down. That will help you out. I'm going to go ahead and do the solutions in black ink right now. So one of the things that you'll notice, let me put that in parentheses here, is that the first 1, 2, 3, 4 problems all have exponents. So if I kind of separate my page kind of like this, these are solving exponential equations. These ones down here are going to be solving some logarithmic equations. Okay? So we're going to start with this. Anytime that we're solving an exponential equation, we want to be able to get the exponent down. We know that the only way to get the exponent down is to be able to do the log ride, and that was log law number 3. Okay, so the only way I can do that is I'm going to try and do a log of it. Now, I can't do a log unless the base, right here, the base of this exponent, is the only thing on the left side of the equation or the only thing on the right side of the equation. So we have to isolate it. So if there was a number in front or a plus or minus that was not in the exponent spot, we'd have to move those first. But since this is isolated, we can go ahead and write this. We can write the log of 4 to the x plus 3 power equals the log of 247,000. Now the log ride law says that this is allowed, right, as soon as we have that. And now I get x plus 3 in parentheses times the log of 4 equals the log of 247,000. So what do I do with this? I'm trying to get the x by itself, so you can see that this log 4 is multiplying this set of parentheses. So I'm going to divide by log 4. I'll show you this on the calculator right here. So I got clear, I got log of 247,000, close parentheses, divided by log of 4. And you can see I get this number right here. And once I do that, I'm going to have x plus 3 equals that number. So I simply have to subtract 3, and I get x equals 5.957. So x equals 5.957. Now I know this is really an approximation, but I'm going to store this just as it is. Remember, we know how to do this, right? We're going to hit the store button right down here, store. And I'm going to store that in x, and I'm going to hit enter, and then I'm going to retype my original problem. So 4 raised to the x plus 3, close parentheses, and it's supposed to equal 247,000. And I get 247,000. And remember, we want to check that every single flipping time. Do that. Okay. So here we go, the next one. So this is a little bit different. This one, I've got a base of 9 here, and I got a base of 9 here. I'm like, oh, look at that. Well, if the bases are the same, then the exponents have to be the same. So I don't have to use a logarithm in this case. I can just do some converting. Again, since both bases are 9 and these are equal, then their exponents have to be equal. So I can simply write 2x minus 5 equals x plus 3. Subtract x here, and I get x, and add 5 there, and I get x equals 8. And that's my solution. You can go ahead and plug it in, plug the 8 into that. And you can see 2 times 8 is 16. 16 minus 5 is 11. So I have 9 to the 11th. And over here, plug in 8. 8 plus 3 is 11. 9 to the 11th. Check mark. That works. Yay. Down here, this one's a little bit tricky because then they're not the same base. But what I'm going to say is this. Look, that's a 25. That's a 5. That's a square of that number. So I can rewrite this, 25, as 5 to the second power, to the 3x plus 6, which is really the same thing as 5, and power to a power means multiplication, to the 6x plus 12. And that's to the x minus 4. And now they have the same base, so that means their exponents are equal. 6x plus 12 equals x minus 4. And I move the x over here and I get 5x, and I move the 12 over there and I get negative 16. And then x equals, what is that, negative 3.2? Negative 3.2. Good? Yay, that's my solution, right? So I put that right up there, and I go, hey, well, does that work? 25, let's again write it in, negative 3.2, so on. So negative 3.2, I'm going to store that in x, like that. Perfect, yeah. So I'm going to do 25 raised to the 3x plus 6, and I get that. That's a pretty small number, right? But we knew it's going to be a negative exponent, right? That makes it small. That really is 0.000009. Now let's do the other one, 5 to the x minus 4. 5 raised to the x minus 4. Hey, I get the same number. Check, check. That works. Feeling pretty good about that. Okay, so now I'm going to do this one. And like, hey, that variable is still in the exponent spot. I don't have the same bases on the other side. I can't do anything with this to make it look like that. So that's why this is not at all like numbers 2 or 3. Okay, number 2 and 3, we had something that we could make with the same basis. So this one's a little bit more like number 1. But you can see that my base is the 4 right here, right? So I got to get rid of this 2 and got to get rid of this 7. Remember, we've talked about this, PEMDAS. PEMDAS has to go backwards when we're solving. We're going to undo stuff. So my first step is to plus 7. Plus 7. So now I get 2 times 4 to the x equals 87. Divide by 2, divide by 2. I get 4 to the x equals, is that 43.5? 43.5. And now I can log both sides because my base is all by itself. So I'll log both sides. Log of 4 to the x equals log of 43.5. Take my log ride because I can do that now. X log 4 equals log 43.5. Divide both sides by log 4. Divide both sides by log 4. Log 4. Make sure you put log on both of those and close parentheses after your thing. So log 43.5 divided by log of 4. Just like that. Hit enter. 2.72. Store that in x. So again, I got x equals 2.72 approximately, right? I'm going to store that in x. I'm going to retype my original equation. So I got 2 parentheses 4, close parentheses, raised to the x, side arrow to get it down, minus 7. And supposedly this is going to equal 80, and it does equal 80. Good deal. Now, here's some common sense stuff. I'm hoping that you can do this. Let's guess right now in the very beginning. Let's say that x was 2. Pretend we didn't do any of this stuff. X was 2. 4 squared is 16 times 2 is 32. 32 minus 7 is 25. I did not get to 82. It's too small. 3. 4 cubed means 4 times 4 times 4 are 64. 64 times 2 is 128. 128 minus 7 is 121. So 3 is too big. If I know my multiplication tables pretty well, like I do, and I'm hoping that you continue to practice on them, you know that your answer within a few seconds of this problem is going to be somewhere between 2 and 3. We did do the math. We got 2.72. We rock stars. Here we go. Okay, so now 4, 5, and 6 are completely different problems. We're going to use the switcheroo on the logs to write it as an exponential equation. Do it that way. Or we're going to use properties of logs and see if it looks like that. So this says a log of this. I'm trying to find a value. So I'm going to change this, right? So I'm going to change this by saying the base to the number over here equals that. So 3 squared equals 2x plus 6. That's our conversion, right? We did this several lessons ago. And if you practiced it enough, it's pretty okay, right? So 9 equals 2x plus 6. Subtract 6, subtract 6. 3 equals 2x, x equals 1.5. You can check it on your calculator, assuming that you put in a base of 3. Good deal. I'll take you through that one more time on this calculator. So I got 1.5. I'm going to store that in X, just like that. And then I'm going to do log base, right? Log base on my calculator, math, log base. My base is 3. My expression is 2x plus 6. And I'm supposing that is supposed to equal 2. And it does equal 2. Yay, I did it right. Again, if you don't have that log base, you can literally type it in. 2 times 1.5 is 3. 3 plus 6 is 9. And then you would do log 9 over log 3. But you have to type them in. You can't make that log of 3. That doesn't work like that with an extra log in the bottom. This one, log law number 1 says that the log of 2 expressions like this with an addition sign in the middle, again, log and a log with an addition sign in the middle, means I have to do a single log of their product. So log of x squared minus 2x, right, equals 3. So I multiply those two things together. X times x is x squared. X times negative 2 is negative 2x. This is a base of 10, right, because it wasn't written, so it's implied base 10. So then I could do what I did on problem number 4. I do the base raised to that equals that. So now I get 1,000, because that's 10 to the third, equals x squared minus 2x. Whew. And then I write, set it equal to 0, right? So 0 equals x squared minus 2x minus 1,000. Now I need two numbers to multiply together that equal 1,000 that differ by 2. So I'm going to do some quick checks on this. Let's do 24 times 22. See, that was too small, right? That's 528. I need to equal 1,000. So let's go 30 times 32. That's 960. So 31 times 33. That's 1,023. So you can see that I'm not going to get a whole number right now. That was my quick way to check some factoring. So then I can just go to my calculator and I can do this, right? X squared minus 2x minus 1,000. X squared minus 2x minus 1,000. I know that that's what it is supposed to equal. I want to know where that equals 0. So on my window, I'm going to go for an x min of negative 40 and an x max of 40, because I think it'll probably fit in there someplace. And here's my graph. Those are my two solutions right there. Second trace, number 5 intersection, enter, enter, enter. Here's one of them, 30.63, negative 30.63, negative 30.63, and second trace, number 5. Remember, I got to move my cursor way over here, closer to the other one. Way over here, closer to the other one. There we go. Enter, enter, enter. And I get 32.63 and 32.63. So I can use my graph to be able to do that. I also could have used the quadratic formula or tried completing the square, but I think this is the faster one. Now what I have to do is I have to be able to check. So this problem and this problem, if I take those and I plug those back in, you'll see that on this one I get a log of a negative number. Watch, take a look. This is what a logarithm looks like, yes? So are there any negatives? Are there any values over here that's negative? And the answer is no. So this thing gets a special name. It's called an extraneous solution. It's a solution that we got when we solved the problem, but it doesn't work in the original, okay? So extraneous. If I actually plug those back in, this one is real, and it does work. Remember, 32.63 is kind of rounded, so it's not going to be exact, but if you plug it in, it should be okay. Okay, over here, now let's try this last one. Kind of running out of time. I got to kind of go through this. So this should be the natural log of x squared minus 4x, yeah, equals 6, because I can multiply those two together. Remember, what's the implied little base down here? It's in the base of e. So I can rewrite this as e to the 6th equals x squared minus 4x. E to the 6th is an actual number. Turn it on. Home screen, clear. Second function, e to the 6th, enter. 403.428. So 0 equals x squared minus 4x minus 403.428. And you don't want to try and factor that, do you? That should just be obvious, right? Yeah. Graph it. Stop the video. Try it. See if you can get it. I'm going to show it to you in just a few seconds. Jeopardy theme music. Dun, 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 dun. Nope, that's not Jeopardy, but whatever. Hopefully you're trying it. Here we go. So I'm going to go y equals. I'm going to go clear. I'm going to go x squared minus 4x minus, look what I'm going to do. I'm going to actually put in what the answer was instead of rounding it, e to the 6th, and hit graph. You can see that I have two solutions. At this point, we'll find out this one is extraneous, but I'm going to find it anyways. Second trace, number 5 intersection, enter, enter, enter. So negative 18.18 is extraneous. Negative 18.18 is extraneous. Again, because when I plug it into here, that would make a log or a natural log of a negative number. It's not extraneous just because it's negative, but when you plug it in, if the result was still negative, then it's considered extraneous. Like if this said x plus 40, then plugging in a negative 18 would still make this a positive number and it would work. Okay, so just because it's negative doesn't make it extraneous, only if the result when you plug it in makes it negative. Then I do the other one, second trace, number 5 intersection, move my cursor way over here, enter, 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 22.18, 22.18, and that one's real. That's the one we want. Well, actually, we want them both. We just need to know that that's extraneous. Hopefully this was beneficial to you. I know I went kind of fast. That's what's awesome about these videos. You can stop them, pause them, look at them, take your time. You can go get a snack. You can go say hey to mom or dad and tell them how much you appreciate them for giving you all the stuff that you do have. I know it doesn't always seem like that, but I know that we really do need to be appreciative of everything that they do for us. And if you're not appreciative, you will be. You will be. I got 3 kids in college right now. They are there. So if parents are listening in the other room, hey, here's one for you. Help them. Help your kids out. Kids help your parents out. Everybody needs each other right now. It's Mr. Bells. We'll talk to you later. Make sure you do the homework on your own.